Hello everyone, welcome to another lecture in biochemistry. Today we are going to see about electron transport chain. The electron transport chain, where does it happen? Or what is the energy source that fuels the electron transport chain? This is the mitochondria. This is the mitochondrial matrix. The innermost, the core is known as the mitochondrial matrix. Obviously, this is the outer mitochondrial membrane and this is the inner mitochondrial membrane. So, the electron transport chain happens in the inner mitochondrial membrane. As you see, these four complexes are the main constituent of this electron transport chain and they are present in this inner mitochondrial membrane. What is the energy source that drives this? The energy source is the electrons that comes from molecules like NADH and FADH2. From where are the molecules NADH and FADH2 generated? They are generated from the TCA cycle. So the inner mitochondrial membrane is also known as the powerhouse of the cell. What is the job of this electron transport chain? The job of the electron transport chain is to make adenosine triphosphate, the ATP. They are the main energy currency of the cell. These protein complexes, that is complex 1, complex 2, complex 3 and complex 4, they are all like conveyor belts. One has to imagine these protein complexes as conveyor belts. The electrons those that comes from NADH and FADH2 will move through complexes 1 to 2 in the mitochondrial membrane, just like how the baggages move through the conveyor belt. When they move from complex 1 to complex 2, then the energy is released. So that energy is used to pump protons from the inner mitochondrial membrane into this space, in the intermembrane space. After that, the ATP is produced. So with the electrons moving from one complex to the another, the protons are pumped and the proton gradient is formed here. So this is because, how does the proton pump? That is because the electrons, when they move through the protein complexes, they will release energy at each step. So the released energy will pump protons from the mitochondrial matrix into the intermembrane space, which is the space between the inner and the outer mitochondrial membranes. Now this creates now the proton is the concentration of proton is higher in this intermembrane space, isn't it? So this creates a proton gradient, meaning there are more protons in the intermembrane space than in the matrix. So once there are more protons, once the proton gradient is generated, or when there are more protons in the intermembrane space, now the protons will flow through this ATP synthase. So see, this is the ATP synthase and the protons flow through the ATP synthase into this mitochondrial matrix. We have to imagine ATP synthase like a turbine. So when the proton flows through this, the turbine starts spinning and ATP is generated. So this is how ATP is generated, and for each glucose molecule which is entered and through the TCA cycle by formation of NADH and FADH2, around 32 to 34 ATP molecules are produced. So why do we need oxygen? So this is how the ATP or the energy is produced. So what is the role of oxygen in a cell? We know that electrons are passed through a series of protein complexes from complex 1 to complex 4 in the electron transport chain, isn't it? Each complex will transfer the transfer the electrons down this concentration gradient. When at complex 4, the electrons have to be passed on to something, isn't it? The electrons have been passing from 1 to 4. Now the electrons have to be passed on to something. That something is oxygen. Oxygen will accept the electrons at the complex 4. And the protons are also entering into the mitochondrial matrix. After a while, the oxygen will accept the electrons as well as protons and forming water. This reaction, that is the formation of water from oxygen, is essential to prevent the electrons from backing up in the electron transport chain. Otherwise, if the electrons are not accepted by oxygen properly, then the electron transport chain will stop because the electrons have nowhere to go. This will halt the pumping of the protons and disrupting the proton gradient, and finally stops the ATP production also. So what do you understand by uncoupling? Uncoupling is nothing but normally the through electron transport chain, protons flow through ATP synthase. So this is the ATP synthase, thereby producing ATP. But uncoupling means that protons will bypass this ATP synthase and it will enter into the inner mitochondrial matrix. So only if it goes through this ATP synthase, then the ATP will be produced. But if it directly, without passing this, if it bypasses and enters into the mitochondrial matrix, ATP is not produced, but instead energy is produced, and that is dissipated as a heat. So uncouplers will cause heat production. So what are the uncouplers? Uncouplers are, the clue is death. D for dinitrophenol, E for ethanol, A for aspirin, and TH for thermogenin. There are also some complex inhibitors. What are the complex 1, complex 2, complex 3 and complex 4, isn't it? So the complex 1 inhibitor is rotenone, complex 3 inhibitor is antimycin, and complex 4 inhibitor is carbon monoxide. So in uncouplers, the protons will bypass the ATP synthase and it will leak, thereby producing heat, but instead of making ATP. But to compensate for this insufficiency, since ATP is not produced now, but still we want ATP for our cell, isn't it? So to compensate for this insufficiency, the electron transport chain will work harder, meaning that more electrons must flow through those conveyor belts, that is complexes. And when more electron flows through these complexes, we need more oxygen is required to accept the additional electrons. So this is how, when there are uncouplers, more of oxygen is required for that person. So let's see a question which is asked on the USMLE. A 45-year-old wood worker exposed to wood preservative that increases cellular heat production. What is the mechanism that is happening here? The mechanism is, we know that the electron transport chain, or else it is also known as oxidative phosphorylation. The mechanism that happens here, which increases the cellular heat production, is uncoupling of oxidative phosphorylation. What is that preservative which is present in the wood? It is 2,4-dinitrophenol, which we previously abbreviated for D in death, which is a known preservative. Now this dissipation of proton gradient leads to increased heat production instead of ATP synthesis. Now we have come to the end of our electron transport chain lecture. I have an announcement for you all. I am starting my mentoring lessons for medical graduates and USMLE aspirants. If you like my videos and if you want to get mentored by me, feel free to send a message in the comments and fill my Google form. Looking forward to see you succeed. Have a good day. Thank you.